This is the 1-1-I lesson. In this one, we're going to kind of do like we did in H. That's why we're doing these lessons together. But the new thing is we're going to actually be creating the word problem or the story problem. And the first couple, we're going to have like a sentence frame. We want it to sound sort of like a module context in that when we write it out, we're not going to see variables show up. And we're not going to just put a plus sign in here. We're actually going to try to use the vocab or the words so as to maybe stump somebody if they were to try this. So we see here is our let statement, our sort of setup. We have person Abigail, whose age is 8, and Brady, whose age is A plus 5. Let's look at our context. Brady is 5 years older, all right, plus 5, than his sister, or it must be Abigail. She's the reference point. If the blank of both their ages is, okay, so we use this, and we now need to tell people build this. So to tell them to build this, we need to tell them to take these two things and add them. So we could say add their ages, or we could use the word sum. If the sum, and when you go to build these, if you use a different vocab word, that's okay. But you don't want to just tell somebody like this, hey, just plus them. Try to trick them by using vocab. If the sum of both their ages is 7, what is their current ages? All right, so we made the context, and now what we're going to do is we're going to solve it. So we're going to combine like terms because these parentheses do nothing. We're distributing a 1. So we have 2a plus 5 equals 7. We're going to minus 5 on both sides. All right, and so Abigail is a year old, and Brady, when we plug this in, is 6. Now, we start off with easy examples. You might have been able to guess this answer once you saw it had to equal 7, but you're still solving it. And also we get nice answers because you can't have a negative age, although you can have a fractional age. All right, we're going to try another one. Feel free to pause the video. So we're kind of doing the same thing we did, but we're now responsible for building the context. We have somebody that's training for a triathlon. So before you worry about this, you're going to look over here. So a triathlon has swimming, running, and biking. And we see our reference point is going to be swimming because that's X and everything is in reference to X. Also, before we go about filling in our story, and by the way, if you want to start with solving it, you can. Let's also look that X has a 3 here. 2x has a 4 here. 2x plus 30 has a 2, and we have 510. So that means also that we're going to have to talk about these top items, but then we're also going to have to tell somebody about this bottom equation, like how to build it, without just saying, hey, build this. Let's see what the story says. Theo's training for a triathlon, so they pick somebody's name. You can pick whoever. He runs twice as long as he swims. Okay, so we already have, let's kind of check these off as we go. So we have this and this already wrapped up in that first sentence. He bikes something. So we're going to say he bikes, we're going to describe this. He bikes 30 minutes more than and we could either say 30 minutes more than he runs, or we could say 30 minutes more than twice the amount that he swims. Let's choose 30 minutes more than let's choose this one where it always goes back to swims. Let's read it again. 30 minutes more than twice the time he swims. All right, we got this now. Now we're going to go to telling people to build this. He swims 3 times a week. Got that. He runs 4 times a week. Got that. That's why there's a 4. And he bikes twice a week. If he spends a total of 510, got that. How many minutes does he spend on each exercise? Make sure you include the sentence and make sure you include the 510 when you build these on your own. Okay. You're going to solve this one and pause the video. Remember that these 4 and 2 are just going to be 8, and then this one does need to be distributed. All right, you hopefully have solved this. I'm not going to show the work, but you should have work. And the answer is 30. And then we're going to plug 30 back in. So you got your work in here. So if this one's 30, then this one is 2 times 30, which is 60. And this one is 2 times 30 plus 30, which is 90. All right, so we've got 30, 60, and 90. Feel free to pause that video if you need to kind of think about that one more time. Make sure you do have your work in here. I don't have it, but get your work to match up with 30 or check with somebody in your group. All right, for the remaining problems, we are going to focus just on the context. We are not going to solve this stuff over here. If you want to solve it, awesome. In the homework, you do need to solve it, but just to now focus on the key things. Since we've practiced a lot of solving equations, we're going to focus on context. Number 3, we're going to write this context. It says, well, first off, let's look over here. So this is going to be buying lunch and buying a pear, a juice, and a sandwich. And then if we look here, we're going to buy those items, and it's going to equal $3.50. All right. The cost of a lunch that consists of a pear, a juice, and a sandwich is, let's put $3.50. All right, so we got that. By the way, you can tell that this person bought one of these, and one of these. There's no extra numbers in front. All right, next, the juice is 1.5 times, right? 1.5 times. There's not much room here to write out 1.5 times. Notice I didn't put the juice is 1.5x. We're not putting a variable here. We're letting the person that solved this think and maybe struggle for a minute about what's our reference point. The cost of the pear and the sandwich costs $1.40 more than the pear. And then they posed the question, what's the cost of each item in the lunch? All right, so we have that word problem, and we've included all of this stuff. If you're going to solve this, just to practice it, this comes out to be 60 cents, 90 cents, and $2 if you want to try it. All right, we're going to go to just a couple more where we're going to focus on building the context. The last two, we're going to look at an angle problem, number 5. We're going to write our context, it's entirely blank, and then solving it on these is optional, not on the homework, just on the lesson. All right, we've got 2 angles, and 2 angles that add up to 90. Okay, adding up to 90 is called complementary. Adding up to 180 was called supplementary, complementary. All right, so we're going to talk about these items here. We can even talk about the last thing first. First, we could say angle A and angle B are complementary. All right, add up to 90. This is not a triangle because you need 3 angles, and in a triangle they add up to 180. All right, now we're going to talk about, this might be the trickiest part, angle B in reference to angle A. Angle B is, and it's backwards, so we need to say 5 less first, even though it happens at the end. 5 less than 4 times angle A. What are the measures of the angles? All right. If you choose to solve this, you're going to get that angle A is 19 and angle B is 71, but that's optional. Last one we're going to do is number 6, where we have, again, feel free to pause it though, just a blank spot where we're going to try to make a context. This time we have a rectangle, and we're adding up our W's twice and our L's twice. So this must be a perimeter problem. So we'll say the perimeter of a rectangle is, and it's 46. So we'll say 46 feet. You can pick whatever units you want. All right, now we're going to talk about the length in reference to the width, and the length is 5 more. So we'll say if the length is 5 more than the width, what are the dimensions or side lengths? All right, make sure you include all of the info. Don't tell them to use W as your variable. Try to use as many words as possible as far as not saying, like maybe even spelling out the word 5 just to trick people. It's not necessary, but it is helpful. If you choose to solve this one for practice, the answers are 9 and 14. And that was the last part of this lesson. This lesson was on making our own contexts going backwards with word problems.